The chemistry behind baking a cake. Cakes were first found in ancient Egypt. These cakes were more like a sweet bread than what is now known as a cake. These cakes were used in religious ceremonies. The first icing was made for the purpose of putting a gloss over the cake. It wasn't until the middle of the 19th century that modern cake was made with flour and baking powder. There are many factors that go into baking a cake that determine how your cake will turn out. Some of these, which we cover in our presentation, are the browning reaction, which is known as the Maillard reaction, why do cakes rise, gluten formation, eggs which act as a binding agency, cake reaction with nonstick spray, and temperature and baking time. Gluten's main purpose in a cake is for volume, texture, and appearance. Gluten is in most flours, used in cakes, breads, muffins, etc. Gluten is made of two different proteins. Gliadin, which is C29H41N709, and glutenin, which is a form of gluten. These two proteins are bonded with water, using disulfide bonds. Cake flour does not use as much protein as bread does, as cakes only need 6 to 8% of gluten proteins. As the flour is combined with wet ingredients, it begins to be mixed. The bond between gliadin and glutenin becomes stronger and stronger. Gluten helps to hold the shape of your cake as well. Sodium bicarbonate, also known as baking soda, is a salt containing two ions, Na plus and HCO3 minus. When combined with a wet ingredient, baking soda dissolves and the two ions split. The Na plus doesn't react with anything. However, HCO3 minus reacts with any acid to produce water and carbon dioxide in a reaction called an acid-base reaction. These CO2 bubbles expand in the oven, causing the cake to rise. When a baking temperature reaches 300 degrees, the sugar bonds with amino acids and proteins. The result is browning, which forms a dark brown crust on the exterior of the cake. Without the Maillard reaction, the cake will be very bland and the cake will take longer to cook. The less heat, the longer the Maillard reaction takes. This is why, in a cake, it happens pretty quickly in the oven. The Maillard reaction is a non-enzymatic reaction, meaning that this is a chemical reaction that occurs when sugars and carbohydrates are heated. First, the sugar is reduced and bonded to an amine group, which causes the formation of glycosylamine. Then the glycosylamine undergoes a reaction called the Amadori reaction, creating amino dioxyfructose. Amino dioxyfructose is eventually polymerized with the help of a furan derivative to give the browning color on the top. The Maillard reaction gives the taste, aroma, and beautiful color that we all love about cakes. If a temperature doesn't reach at least 300 degrees, then the amino acids and sugars will remain as separate compounds and will not bond together, which will form the solidified cake. The baking time will determine the cook time. Baking a cake is an endothermic chemical reaction. The heat from the surrounding, which is the oven, is coming into the cake, which is the system, causing an endothermic reaction to occur to make a beautiful cake. All these ingredients previously talked about work together when put into the oven. The heat has a major effect on your cake. First, the leavening agent, which is baking soda, expands. The CO2 bubbles that are formed expand with the heat in the oven into the batter and the cake surrounding them. Due to this high temperature, water vapor is formed. Vapor is formed from the water and the butter and eggs. Both of these gases and bubbles expand but do not burst. This is because the gluten in the flour keeps them all intact, binded, and stable. Preston took out the eggs in cake number 2, which you will now see at the end of the presentation. In general, eggs can play a major role in the color and texture of the cake. Egg yolks bind ingredients in the cake together, such as water and oil, which do not mix due to the water's strong hydrogen bonds. Eggs contain a phospholipid called leucine, which is used as an emulsifier in baking. Lecithin has a head that suspends into the water and a tail that gets suspended into any fats, such as oil. This allows the eggs to combine the two ingredients that normally would not combine. Because of this, too many eggs cause a rubbery texture in the cake because they are such a big binding agency in the cake. Too little eggs can cause the cake to fall apart. Fats are organic compounds that are made up of carbon, hydrogen, and oxygen. Fats belong to a group of substances called lipids. Lipids are mainly found in oils, butter, fatty acids, etc. Lipids are essential macronutrients. This is why cooking spray is able to be a healthy, less fatty alternative to butter or oil, because they're all lipids to an extent. Non-stick cooking spray comes in many different types, such as canola oil spray, coconut oil spray, olive oil spray, etc. Cooking spray is a lower calorie, less fat alternative to butter or lard or other lubricants. Non-stick spray is an aerosol oil essentially. However, it also contains lecithin, an emulsifier just like eggs. Dimethylsilicone is present in cooking sprays as well as butane and propane. Dimethylsilicone is an anti-foaming agent, and butane or propane are both hydrocarbon propellants in cooking spray. All of these ingredients combine to make sure your cake comes out in one perfect piece.